also be aware that the question and answer sessions and the text chat will also be using that as a record of this session. So just be aware of that. And yeah, we're going to get started. Welcome to the GEO LDN Technology Innovation Competition. Today is our demonstration session, and I think we're all excited to see the demonstrations of the three concepts of the three proposals here presented to you live. And we hope you're all open, ready, and willing. We hope all our demonstrators, all our contestants are ready. We know you're all probably a little nervous. Let's go through some of the structure of the session, just so you have an orientation here. The session will be interpreted, so you do have those options at the bottom of your screen there. If you click on one of the language options there, you can get the French or the Spanish simultaneous interpretation. And we thank our interpreters. Quite a daunting task here to simultaneously interpret the entire session. So thank you all in advance. And of course, you have different ways of interacting during the session. I'm just going to go over this very briefly. We can help you if you're having difficulty when it actually comes time to activate these different features. You have the Q&A window by clicking the icon. We will be using that during the Q&A session, of course. If you're an attendee, you can ask questions. If you have a speaking role, you can only answer the questions, and those Q&A sessions will be facilitated as well. And yeah, you can use you can raise your hand by using the hand symbol if you are a panelist. So just a very brief overview of some of the basic functionalities here in Zoom. And also, for all attendees, you can contribute, of course, in the text chat. We would like you to do that. You can raise your hand and you can ask a question. So you have quite a lot of features if you're an attendee. And we're going to warm up. I know some of you are nervous about the session, so we want you to relax a little bit and warm up. And we're going to be doing a kind of guessing game associated with demonstration sessions. And I want you to vote in the text chat. So just make sure your text chat is fixed on all panelists and attendees. And Astrid is going to type the options in the text chat. I'm going to ask you 3 questions. So what I want you to do is Astrid's going to type in A, B, C, D as options, and just give a thumbs up to what you think is the correct answer. And I did a little work in Google Translate, and demonstration session, we had that translated by Google into various phrases, various languages. Of course, we see here Hindi and Vietnamese and Icelandic and I think Dutch and of course Greek here. Which one is not a proper translation of demonstration session? Give me a thumbs up on A, B, C, D, or E. And I'll ask Astrid to be my eyes and ears here since I cannot see the chat.
So I see 2 A's, 2 D's, 1 C, and 1 B. So it's okay, not very.
So we have a lot of people here in the session, so please do vote.
1, 2, 3. There's also a Y coming.
Why?
Which is kind of funny.
Why vote? So which one is not a translation of demonstration session? Of course, you have to use your maybe your intercultural skills, your guessing intuition, maybe.
So we have 6 A's, 3 E's, and also 5 D's. Okay. It's not very clear. I think you have to give it.
Okay, the correct answer, the one that is incorrect, of course, which is not a translation of demonstration session, is in fact B. B is Vietnamese for acrobatic demonstration, so quite different from what we'll be doing today in our session. I have another, let's say, linguistic question for you. The word demonstration in English first appeared in English when? Is it late 12th century, derived from the Arabic, 14th century, derived from Latin, Polish demonstracja in the 15th century, or mid-15th century coming from the Italian? What do you think? A, B, C, or D? And I'll ask Astrid again to type the options and give us a thumbs up. Where do you think the origins of the word demonstration come from?
So we have 6 Bs for now, 2 Ds and 1 C at the moment. But I think, yeah, there are more Bs coming in, which sounds quite funny. We have 7 Bs now, also 1 A.
Right. Okay, those of you who studied your Latin, B is correct. Of course, the demonstration does come from the Latin. And I have one more kind of warm up for you that has to do with today. Somebody has a birthday today. Somebody was born on March 9th, 1454, and it's this gentleman. Who is it? Who do you think this person is? Is it A, Amerigo Vespucci, B, Fomaro, or Gerardius Mercador, or Nicholas de Fer? Who is this birthday person today?
Yeah, so we have already 6 Cs. Oh no,
it's a C?
3 A's. So I'm not sure if it's A or C, but I think most of the people vote for C.
C, okay. Well, I hate to disappoint you, but it is Amerigo Vespucci, the famous discoverer, cartographer, who was born on this day in 1454, so on the 9th of March, 1454, which is a kind of nice date to tie in with our demonstration session. It was such a famous cartographer, and of course, he would have used an astrolabe, and of course he did use an astrolabe. And as one of our jurors pointed out to us, I wanted to tie in the astrolabe with today's devices and today's technology. And one of our jurors pointed out that sometimes the astrolabe is better depending on cellular connectivity and Wi-Fi connectivity. So maybe the astrolabe is sometimes more reliable, but we've come a long way from the astrolabe, and that's what we're going to be looking at today, how long we have come from that early device in the 15th century. Our agenda today, we'll start off with some welcoming remarks, then a very brief overview, kind of introduction to the competition. Then we'll get to the real core of today's session, the 3 demonstrations. That will be followed by general Q&A, and then we'll wrap up and tell you a little bit about next steps. And we are going to end punctually at 1400 hours CET. So that's what you can look forward to today. And I'm going to hand over the microphone right now to Neil Sims, who's going to be giving you a few welcoming remarks. Neil.
Thanks, Michael. G'day, everyone. My name's Neil Sims, and my day job is at CSIRO in Australia, where, amongst other things, I have led the writing and the revision of the Good Practice Guidance Report for SDG Indicator 15.3.1. I'm very proud to be one of 3 co-chairs of the GEO LDN initiative with Antje Hetchelchen and Amos Karbobar. And along with Alex Zvolev from Conservation International, I co-lead Working Group 3 in the initiative, which focuses on supporting data analytic systems for LDN, and which is the inspiration for the competition that we're in today. The competition, which aims to identify and develop a software tool to help countries assess the neutrality of their land use choices, is aligned with Working Group 3. So tonight's demonstration is the fourth phase of the competition, which to date has included an initial process in September last year to identify the most promising of the original entries, followed by 3 presentation activities: a virtual pitch on the 30th of October, a sneak peek on the 10th of December, and the demonstrations that we will be seeing today or tonight, depending on where you are in the world. We received entries from 23 teams with participants from 36 countries across every continent, which was a fantastic reception. And we now just have 3 teams remaining. The next and final phase will be a demonstration of the remaining 3 proposals and the presentation of the award to the winning team at the upcoming meeting of the UNCCD CRIC, which is the Committee to Review the Implementation of the Convention, which will be held on the 19th of March. All of the proposals have been reviewed by our panel of experts who provided excellent insights into the potential of each proposal, and we're very grateful to everyone who contributed to that. It was very valuable. Thank you very much. We also are very grateful to some recent support people here in the competition, 2 land use planners, Jenny Lee Kohima from the Namibia University of Science and Technology, and Trevor L. Ben from the Guyana Lands and Surveys Commission, and along with 2 of his students who provided some most valuable insights into the planning process during Astrid Moller's sessions on human-centered design. We hope this has been a really interesting and useful thing for the teams to have gone through. I've been fascinated by it. The final decision on which proposals would move through to the next phase was made by our jury, of which I am the chair, using a consistent and rigorous assessment process at every stage, and we'll go through that again after this demonstration tonight. And the whole process has been very ably supported by a wonderful support team who've excelled in each of their roles. I won't name them. Each of these people you can see on screen has done a fantastic job, and we're very grateful to all of them. We've been particularly fortunate to have received financial sponsorship for the competition from the Federal Ministry for Economic Cooperation and Development of Germany, that's the BMZ, and the UNCCD Syngenta Soil Leadership Academy. And I would like to extend our sincerest gratitude to both of these institutions on behalf of the GEO LDN. And thanks to our sponsors, the winner of the competition will receive support to develop their proposed tool into one that is used operationally by countries to integrate LDN into their land use planning activities. There's 127 countries have committed to setting LDN targets, and all of them will have the opportunity to use the winning tools from this competition. And this is a fantastic opportunity for you to have global impact on an issue that is of critical importance to the sustainability of our environment, and also to the livelihood of literally billions of people. It's quite a responsibility I think we've got here as well. So thank you all very much, and I wish all the teams the very best of luck.
And thank you, Neil. We are coming at this point now to the demonstration sessions, and let me just outline the procedure. Each finalist has exactly 20 minutes to present their proposal and 10 minutes for follow-up questions, which will be facilitated. After all of the demonstrations, there'll be a 10-minute just general question and answer segment. So 3 presentations, 20 minutes each, followed each time by a 10-minute question and answer, and then at the end of the 3 presentations, a 10-minute question and answer period. And we come to our list of presenters here. We have proposal F, L, and N. The first one will be Claudio Zucca presenting, followed by Vanya Westerberg and Pythagoras Kamarapipoulos. That brings us to our first presenter, Claudio. And Claudio, I'm going to stop sharing so that you can take over.
Yes, before starting, I would like to ask Arindam, our colleague that is intended to share the screen to try to test it, because we could not do it before. Sorry about that. If it is possible. Arindam, are you there?
Yes, sir. Is it visible?
Okay,
We can see
I
your
see.
desktop. Mhm.
I see everything is working. We hopefully. Okay, so sorry for that. So now we can start. Okay. So first of all, good morning to the jury members, ladies and gentlemen. Let me say that we are honored to be here. My team is grateful to the jury that selected us for the final round of this long journey. I am pleased to say that we have new team members. We have a second test area in Mongolia and Gobi, and we have local users. Like in India, also in Mongolia, we have a local planner and a local scientist, and in addition, there we have a donor. The Mongolia-Korea Green Belt Project, a large project to combat desertification, has endorsed our tool for site selection and for monitoring. Also, I am honored to announce that Ambassador Byung-Yeon Kwon, one of the 6 UNCCD land ambassadors, has endorsed our tool and joined the team. His international NGO, Future Forest, will employ the tool for site selection, for action planning, and for monitoring. And Future Forest will also support the tool development beyond this competition. So we have different users in our team. They all need to evaluate the impact of their land use planning decisions in terms of land degradation neutrality. In India, the use of the tool is linked to institutional land use planning. Our users adopt participatory integrated landscape management processes that are promoted by UN agencies, including the UNCCD, and are increasingly adopted in developing countries. In Mongolia, the tool supports planning of land use change actions that are promoted by international donors, but are done in coordination with local authorities and are aligned with the local land use planning process. Our land planners need to report on LDN using the SDG indicators. However, to take planning decisions, they also need other information. To set priority, they need to know where land degradation processes are most intense. To identify actions, they need to know the nature of the land degradation processes and the drivers. However, from Asia to Africa and beyond, they often work with old and low resolution maps of land resources. This is amazing, considering the tremendous increase in availability of EO data and the processing and modeling capacity. So this is our vision and ambition, a tool for LDN that also provide users with state-of-art information that they need to support the concrete planning decisions to achieve land degradation neutrality on the ground. Our tool is complex and challenging. We did our best in little time with no budget. Our tool, unfortunately, is not complete 100%, as you will see. Our implementation team is made of students, and a student, in fact, will present the demo. We are proud of that. Questions will be answered by our technical implementation leader. Please understand that our system has a complex structure. It does not recombine available data set. It generates data through complex procedures. This requires processing time. For this reason, we cannot show full real-time demonstration of the workflow. We will show a combination of interface descriptions and short video animations. We also developed preliminary user manual with step-by-step guidance, and we will use this to guide you through the tool module concept. So now I will give the floor to Arindam, one of our best students in the development team, to run the demonstration. Are you ready, Arindam?
Surely, sir.
Thank you. Please go.
Good evening, everyone. So I will be demonstrating the tool that we made. So this software was designed as a plugin in the module of Vue.js, but is also executable in single console mode for batch file processing. 3 plugins have been uploaded imported in the online repository folder, which correspond to 3 layers of tool architecture. So let me demonstrate first of all the installation plugin. So you can simply go to manage and install plugins here, and you can install the plugin from zip files. And let me just install this plugin. So you can just install this plugin by clicking install. Let me move on ahead. So first of all, screen shows the overall system structure. The tool monitors or models and forecasts degradation based on multi-layer structures and their interaction. Layer 0 creates base datasets used for layer 1. Layer 1 creates land degradation. Layer 1 creates land degradation mapping products in 3 different modes: single component mode, intercomparison mode, and focus on mode. Then, layer 2 processing components is a convolutional neural network engine with the input of layer 0 to forecast the land degradation rate in future or based on user-defined scenarios. Layer 2 interacts with land user scenario planner component to compare user scenarios in terms of land degradation neutrality. Users can choose a multiple data processing approach according to their technical basis and demanded accuracy. Let me just say it. The users can choose a multiple data processing approach according to their technical basis and demanded accuracy. Thus, users can follow simple single component mode or compose their own land degradation metrics and forecast future land degradation. The layer 0 user interface is shown in here. User can freely assign required datasets which are available in public domain data source. Can define spatial domain for processing by uploading a shapefile or assigning coordinates and defining temporal domains by setting monthly or yearly average. He can also output data resolution. The default value is 500 meters. Layer 0 is a basic data generation model. We designed this component to extract all required data sets such as surface condition, vegetation index, topographic data, weather information, soil data sets, uh, SDG indicator for LD mapping, and layer 1 and layer 2 using Google Earth Engine API. It was designed to secure or that all processed datasets in local disk and cloud disk, and to not allow for external data access without user permission. Thus, data security will be guaranteed. To secure data compatibility, data format is fixed for WGS84 geographic coordinate system if there is no specific user requirement. Let me demonstrate the layer 0 right here. So this is the user interface for layer 0. You can select the output direct right here. You can select the spatial extent. You can select the output resolution right here, and you can select the temporal extent and the EVI data set that you want, and the level of data processing. Now this process takes a long time because everything is downloaded from the internet through Google Earth Engine API. This is a demonstration video for the same. After the tool is executed, everything is exported into the output directory. And let me just import everything right here. So all these data sets were exported from layer 0, and then we import it in QGIS. And you can see the different data sets, the land surface temperature, wind direction, and all the other data sets that layer 0 generates. Let me move on ahead. Layer 1 works in 3 modes: single component mode, intercomparison mode. In single component mode, it creates land degradation mapping product by multiple models and monitoring approaches such as RUSLE and aeolian erosion model, or empirical orthogonal function WRF DUMO in the land degradation monitoring by INSAR phase coherence approach. The tool also utilizes the three SDG LT matrix based on LC, BP, SOC that are generated in layer 0. These are used by layer 1 as we show. Let me demonstrate the layer 1 single component mode. This demonstrates so this is layer 1 single component mode where EVI is used. This demonstrates EOF analysis on multiple layer 0 projects and on the INSAR time series based monitoring procedure. Users can establish resolutions from 500 meters up to 100 meters for land degradation mapping products. Stated. INSAR land degradation monitoring mode is a very powerful method to monitor relative land degradation rate with 100 to 30 meter resolutions using Sentinel-1 INSAR coverage. Combining EVI with INSAR phase coherence, we successfully covered whole Thar, West Mongolian, and Chinese Kibuchi. Marty Corina's was also implemented in single component mode by replacing WRF Dumos parameters with our aerodynamic data set and ECMWF weather data, which are extracted from layer 0 component. The component provides 500 meter resolution aeolian erosion map as shown in here. Layer 1 intercomparison mode is Layer 1 intercomparison mode is used for the creation of user-defined land degradation mapping products. Based on layer 0 or layer 1 products, users can easily establish their own land degradation indices, including SDG 15.3.1 indicator. Via normalization, for instance, UNCCD global SDS mapping products, users can recontrol all data range and direction consistently. This animation here demonstrates how users can create their degradation map using intercomparison. A layer 0 single component mode uses three empirical orthogonal functions. Analysis results monthly modest protrusion coefficients, modest land surface temperatures, and enhanced vegetation indices covering 2 years time period. Intercomparison mode synthesizes them into new land degradation map via weighted average operations. In the same way, users can also produce new land degradation maps using other layer 0 outputs. Thus, users can establish their own land degradation map.
Arindam,
Mapping.
you should
Yes.
speed up. Arindam,
Oh,
you
okay.
should speed up a
Surely,
bit.
surely, surely. Our most technically advanced component is layer 2 forecasting mode based on powerful convolutional neural network. We are particularly interested in the application of CNN for land degradation forecasting as the underlying structure of training using pooling and convolution fits high-level spatial-temporal range of background environmental matrices. We successfully trained CNN using layer 0 features and the outputs of our INSAR land degradation monitoring schemes. Therefore, other forecasting scheme, for instance, employing SDG indicators will also be possible. This video right here demonstrates this demonstration shows two land degradation forecasting cases with or without user-defined scenario. Without user scenario, the forecasting model estimated land degradation rate only depending on the functioning of natural environmental environment. User-defined scenarios of land use change can be integrated as explained later. Then the forecasting system estimated change land degradation rate by user scenario. This is the output that we get when we use the CNN model to forecast the upcoming land degradation. This is the output, and this is the input that we give to the CNN model. Let me move on here. The scenario builder module will allow users to evaluate the impact of. I'm sorry about this. Is my screen, I think, desktop? Let me give me 1 second. Sorry about this also. Is it visible now? Is my screen visible? If anyone can confirm.
Yes, it looks good.
Okay, thank you. So let me just give me 1 second. So the scenario builder module will allow users to evaluate the impact of scenarios of land use change defined by the users in terms of land degradation neutrality. It will work on 2 modes. In integration with layer 2, it will allow users to compare LD as defined by 2 forecasting outputs with or without user scenario. In integration with layer 1, it will allow recalculating land degradation and dust emission based on changed model coefficients due to user-defined LU change. Unfortunately, the basic model design functions are established but not yet implemented. We are very sorry for that, and it will be implemented in the further use. The forecast. In the forecast mode, the module will allow comparing 2 final stages of 2 predicted trajectories with or without scenario against each other and against the baseline land degradation conditions. The output will be a map showing the net land degradation change obtained thanks to user scenario. Therefore, land planners can validate their projected land use change towards maximizing land degradation gain. User-defined LUC scenario uploaded, example as a shape file. The user land use is compared with the baseline land use, as in below example, where 2 maps are changed in the user scenario. A change matrix is automatically calculated. In model and monitoring mode, new model coefficients are assigned based on assumptions that changed land cover conditions determine a change in relevant coefficients in water erosion and erosion model. Different user-defined land degradation and DE scenarios are compared with the baseline land degradation and DE. The user can also use these projects to further understand the impact of scenarios on the severity of land degradation processes and on the likely of side effects.
Thanks, Arindam.
Let me.
Thanks.
Yes.
I think you have been great. Thank you very much. We just have time to give the floor to Prince from India, representative of Indian user group. Prince, are you there?
Yes.
Yeah, please.
Good morning. Namaste from India. Myself, Prince Prit. I'm working as a principal consultant with an Indian NGO called Arpan Seva Sansthan. We are working all around in country in India. Our work is to support district authorities in.
Please continue, Prince.
Okay, sorry. I thought my video is going on.
Sorry.
Yeah, sorry. Our work is to support district authorities planning land use changes at watershed level and to combat land degradation and to implement action plans accordingly. We do that in our collaboration with scientists from technical agencies like CASRI and stakeholders because land use planning is a teamwork and is a part of integrated landscape and watershed management. This tool helps us in many ways, like it generates high resolution maps showing patterns of land degradation processes and their severity. This provides a good spatial basis for land use planning and to design action plans. Also helps to predict the impact of the land use changes that we are planning and to see if we are moving towards land degradation neutrality or not. As further development, we wish that we can use this tool also for monitoring and assessment of the intervention that we are implementing and use this tool to update the land resources map that we use for planning. This is from my side. Thank you.
Thank you very much. The time is running out and we have no time to show the work plan, but our main message about the work plan is that as we have admitted, we could not make it in these 2 months to realize a fully functional tool, and it is fully functional in layer 0, layer 1, layer 2, and it was a huge achievement, believe me, because it is very complex. And for the user interface and the capability to make the scenario, the basic functions are working, but we could not complete the interface, and so it could not be demonstrated here. We are sorry about that. This, if we ever get affected, will be our work.
Thank you very much, Claudia. And Shukriya, Prince, thank you very much, and namaste to India. We yeah, just in time, and that leaves us with the question and answer session. And I'm going to grab the screen back and go to our presentation just for your orientation here. And I'm going to pass on the microphone to Anna, who's going to just explain a little bit about the procedure, and then we'll get to the 10-minute question and answer session. Anna.
Thank you very much, Michael. And thank you once again to Team F, Claudio, Prince, and Arindan. Just quickly to remind everyone how you can engage in the Q&A session. So for the jury panel and experts, as you were awarded a panelist link, you can raise your hand. Please do so when you have questions or comments and you would like to intervene. For all the other participants in the audience, we ask you to please use the Q&A panel. You will find an icon at the bottom of your screen. Please open and type your questions there, as this is the best way for us to handle them so that we don't miss anything. Other comments that you may have, suggestions, please feel free to also use the chat, but for questions, please do use the Q&A. This is the best way. I'm going through. For now, I don't yet see any questions and answers. Let me check here regarding raising hands. Peter, please unmute yourself. The floor is yours.
Thank you very much. And thank you to the team for this nice demonstration of your tool. I have one question, and that is about the simulation, the modeling you do for forecasting future areas of land degradation. You very quickly, if I captured it right, mentioned you use neural networks for that. Can you explain a little bit more? What are the drivers that you account for predicting that, and how your model is parameterized, and how this uses evidence from prior modeling efforts of trying to predict areas of land degradation? Thanks.
Yes, I'm leaving the floor to Dr. Jungra Kim, our technical implementation leader, to answer this question.
Okay, so first things, the first base idea to bring convolutional neural network is all of land degradation mechanism is exactly fit with the convolutional neural network concept, because one pixel interact surrounding part also back project into original pixel. So it interact certain kind of mechanism. So such kind of mechanism exactly fit convolutional neural network pooling way. Okay, that's why we bring the convolutional neural network, and then we trained this neural network system using interface coherence monitoring result with input feature from Moody's Google Earth Engine, the input vector. So we can estimate the very likely forecasting result perhaps up to 3 years later. Okay, that's why we bring convolutional neural network. So I think that is very short answer, but you can easily catch why we bring convolutional neural network, because of some interaction of spatial pixel. The mechanism ejective fit with convolution neural network spoolings mechanism. So,
Thank you, Greg.
Thank you.
Thank you very much. I'm going to hand the floor now to Doug, one of the jury panel members. And I'm going to ask Peter for a little patience. Peter is one of the participants in Team L. So Doug, please go ahead. The floor is yours.
Thanks, Claudio and the team for this very interesting tool. Obviously, it's very complex. And forgive me if I missed this, but I was just wondering in relation to this prediction based on the neural network component, can you just briefly describe what what kind of a verification cycle do you have? Is there a verification cycle in the tool whereby reference data can be used to judge the the accuracy of the predictions?
Okay,
Yes, please, Jungrad, please.
Yeah, okay, so actually the convolution neural networks, the strongest requirement, we need some kind of target training data. So how we can manage the collection of target training data, we usually call ground truth. So there is multiple ways to collect training data. First, we can see very precise modeling result. For instance, we are currently implementing the WAP GEO model, so we can use the outcome as a ground truth. But we have more practical and more precise ground truth data, which is collected by interface coherence time series analysis. This method has developed for us 10 years more. Recently, our team also makes 3 consecutive peer-reviewed publication for application of this phase coherence method and precision. So we gain very high precision training data. So now we have very powerful convolution neural network engine. We have very precise neural network. That's why we make very high precision result, and we validate using some time series. For instance, we can estimate the mid-time, the land degradation result, and then we can compare this one to forecast the result. So that is one of validation method. The other things, recently, our strong stakeholder provided almost 40 more high sub-centimeter resolution drone data. So in very near future, we will use this data for validation of our forecast. Also, we have almost 130 sub-meter resolution satellite data. So we also validate soon, and all results will be published in peer-reviewed academic journal. Okay, so is there answer?
Yes, thank you very much.
Thank you very much, Jungrad. The earlier question, I apologize if I wasn't clear, was from Peter Verburg, a member of the jury panel. We now have the raised hand from Peter Googles, a member of Team L. Peter, please unmute yourself. The floor is yours.
Thank you. A very quick question. I'm working more in the context of drylands in the Sahel and West Africa, the Savannah, and working on the ground. And one thing that is really important for us is the amount of tree cover, not forest, but the amount of trees that farmers allow on their cropland or on pastures. And I didn't quite understand, or I missed it, if your tool would be able to monitor change over time for the amount of tree cover on cropland. And I was just wondering if you could just briefly explain if it does that and how it does that. Thank you.
Okay, so usually the common method or sort of standard method to monitor cropland or some of vegetation is employing NDVI or EVI. But we prefer EVI according to our test result because it has less saturation issues. Okay, then complementary of this product, what we found, protrusion coefficient, which is extracted from MODIS BRDF, has very important meaning to estimate biomass, because some of land degradation areas biomass do not have signature in NDVI and EVI. So that's why we implement layer 0 to extract the PC, protrusion coefficient from bodies, or in future, we also will modify the system to even extract BRDF PC from Landsat or Sentinel-1. So if you are interested to employ protrusion coefficient, that we can call surface local roughness. You can communicate. We will validate such kind of vegetation monitoring using high resolution, several centimeter resolution drone data. Because from drone, we can directly estimate the biomass. So we will validate our monitoring of comland about vegetation. Okay, so I think that's all.
Thank you, Yungrak. I see the Alex has his hand raised. Please, Alex, be very brief. The floor is yours.
Hey, thank you, Anna, and thank you very much to the participants as well for the demonstration. I just had two quick questions. One was around, and we already heard of some excellent applications, and you mentioned stakeholder engagement in India and Mongolia. Can you talk about the potential to globalize the tool? And then also you mentioned the work plan. Can you just very briefly tell us what additional work you would plan on the tool and on what timeline?
Please, Yungrak, continue. Is the work plan to globalize the tool.
Okay, okay, just one moment. In Mongolian side, the Korea and Mongolian government is promoting, currently conducting almost $20 billion of combat desertification project. So from there, they firmly promise to provide insight data, science data to validate our result. Instead, we will provide the tool to decide the planting area or some policy. So we'll exchange in that manner. We'll exchange, and then based on two results, also we have very strong scientific data gathering place in Fuji Desert. Future Forest, one of the strongest NGO in combat desertification, they will use to define their planting area in central hubs in Central Asia, across Central Asia and India. So we can globalize the use of this tool very effectively.
Yungrak, I apologize. I have to ask you to please conclude as the time is up.
I think the last sentence is important. I hope you get it. You got it. I mean, based on the fundings that we secure from Future Forest, we will be able to have a plan to reach Central Asia. So with Mongolia, northern eastern China, India, and Central Asia, we are confident that we can cover most of the variety of Asia. And then we have plans for Nigeria too. We know that UNCCD is working there, and as also sand and dust storms are important there, our tool can be a support for that. We are establishing contact to collaborate in Sahel. And so we have planned for that.
Thank you very much, Claudio. Over to you, Michael.
Yeah, thank you. Thank you, Anna, for keeping such a great eye on the clock. And thank you, Claudia, for being brief. Yeah, it's quite a challenge, as you see here. We are going to move on now to Team L, to their presentation, to Vanya. I will stop sharing the screen and you can begin with your presentation, please.
Yeah, all good. Okay, thank you.
You can begin, yes.
Thanks very much. So I'm glad to introduce you to our tool, LDN Analytics, that I've developed together with Luis Costa, remote sensing expert, Simon Reynolds, full stack software developer, as well as our consortium members, Groundswell International, CCOD, and PDL. And I'm myself, Vanya Westerberg, an environmental economist at Altus Impact. We're working on this tool with much enthusiasm because we know that land degradation is arguably the biggest challenge of our century. But by addressing it, we also have the responses to helping feed a growing population, unlocking rural growth, halting species loss, and importantly, adapting and mitigating climate change. But somehow there's a failure to understand that soils matter. This shows up in, for example, with agriculture, forestry, and other land use sector being hugely underfunded, receiving only some 3% of finance mobilized globally to fight climate change. And the reason why we're failing to understand the importance of soils is probably because we're lacking the adequate metrics and tools to measure the quantity and quality of our soils and the impact of our land use interventions. So these are reasons why we as a team were motivated to work on enhancing analytical capacities around the measurement of land productivity, even before the LDN competition was launched. Now, with the tool, we've developed it with the view to serving different user groups from local to subnational and national level, and of course, to help countries achieve their land degradation neutral targets, notably by embedding the tool in a land planning systems that allows to understand trade-offs involved in pursuing neutrality, land degradation neutrality. I should say, though, that around the trade-off component, this is where most of the work remains to be done on our end, but we do have a good roadmap and we're developing by the day as we interact with users. As recent as yesterday, we got feedback that we integrated in today's version of the tool. Now, from that, I will now take you to the tool to make an actual demo version, specifically with respect to Haiti, where we have one of our consortium member, Partenariat du Développement Local, operating. So you come into Google Earth and you mention the country that you're interested in and the time horizon that you are looking at first and foremost. This can be considered your baseline. So in this case, we're looking at the last 10 years for which we have data from 2009 to 2019. We come in, we see a picture of what's happening within Haiti. Tiles that are going towards yellow, orange, red means areas that are more degraded. Tiles that are regions here, arrondissement, that are greener means that there's been an increase in land productivity over the 2009 to 2019 time horizon. Our PDL, our consortium member, works in the arrondissement San Rafael. So we may click on that to learn a little bit more about San Rafael. And first and foremost, what we see is that for Haiti as a whole, Sustainable Development Goal Indicator 1531 is 11%, meaning that 11% of the land in Haiti is degraded over the total land area, or the amount of land that is degraded over total land area has increased by 11% from 2009 to 2019. And then we can go in and look within the arrondissement itself, where we see that actually degradation has increased by 22% within that arrondissement. We can then go and try to understand what's happened, what is driving this degradation. Should also mention that the indicator has been calculated using the one out, all out approach, such that if any of the sub-indicators, productivity, soil organic carbon, or land cover, is showing a negative change, then that shows up in a given pixel as there being degradation going on. So with regards to land cover, for example, in San Rafael arrondissement, we can see from 2009 to 2019 that croplands, the number of croplands have increased, grasslands have increased, tree cover has declined. So some of the degradation definitely comes from that decline in tree cover. We may then, as a land planner, go in and look at what is more specifically what's happening within our region. For example, with respect to each of the sub-indicators. For example, we can look at the land productivity, and we see within San Rafael, indeed, a statistically significant decline happening within land productivity. With regards to land productivity, we may then want to say, okay, what's that? Is this land productivity, is it declining on hilly areas? So we can click the terrain map. Let me just take this away. And you can see, okay, we can kind of interact. Let me go. You can see, yes, some land degradation is happening in hilly areas, but also in the lowland areas. We may also want to know if there's any significant erosion risks and target our interventions in those areas where there are erosion risks. So you see that we have some red spots highlighted here. We can look at areas where there's higher intensity of fires, which may jeopardize our restoration interventions if our interest is to regenerate forest cover, for example. we can also look at where there are current drought risks. These are tiles that are a bit more red because we maybe want to probably increase the soil organic matter and the soil moisture in those areas and target our interventions. We will, of course, also improve the coloring. What else? We can also go in and see whether the restoration interventions we've done in terms of increasing reforesting around San Rafael has paid off. So we click the land cover transition matrix, and we see around San Rafael, we indeed have some improvements in land cover. I should say as well, we also, of course, have the data for the actual land cover classes available. So we can see that this is actually forest land, except we haven't made them visible in the tool yet. We also have got, as Peter just mentioned in one of his comments, for some of our stakeholders and end users, actually understanding the tree density within given land cover classes is very important. So we've got a tree cover density map here. And so green areas is where there's high tree cover density, black areas and no trees whatsoever. And yes, indeed, I think for many of the users we've talked with, they're operating within individual land cover classes, croplands or grasslands. Same for both private sector and NGOs. And so they're, of course, interested in layers that can inform what's happening within a given land cover class. And with that, I should also say that, of course, this tool can be built upon. We can add more layers with time. We've got interest, for example, in having soil salinity layers, flood risk zones displayed as well. And other important features would be something like IBAT to show key biodiversity areas, areas where you would maybe want to do some regeneration to help safeguard the species diversity or at least avoid further developments. But Simon will talk more about the development perspectives. So what I will do now is show you a little video from PDL, Ronald Lefranc, responsible for monitoring and evaluation in Haiti, on how they can use the tool. Hup. Unfortunately, I had to cut him.
First of all, I think it's a very interesting tool and with very easy to interact with in terms of the user interface. I believe that we can really use this kind of tool in our work daily or yearly. First of all, in the planning of our work, in prioritization of our annual plan, where we can see, okay, this is one of the areas that we need to focus more efforts being compared to other areas that where we are working. And also, I think I mentioned that before, it can be also a very good tools to demonstrate to local, regional, and national decision makers that agroecological farming, that the techniques and the practice that we are promoting can be really important and can contribute to land degradation neutrality and disaster risk resilience by being able to showcase with clear examples how some of the indicators have changed with the impact of our work. And also, I think that can be eventually used to support policy support and finance for the work that we are doing in these areas. In terms of improvement for further development, I think one of the important aspects I would like to see is that we use a higher resolution in terms of using a municipality as a unit of measure, because I can see now it's at arrondissement, which covers several communes at the same time. It would be great for us to see, like, we are working in Saint-Michel, we can take Saint-Michel separately and analyze our progress in this area, and take Saint-Raphael itself or Mobekoshi itself and see how we are progressing in these areas. And the last aspect I think I would mention in terms of priorities is being able to export these images with the graphics that we can see in order to use them in the reporting, in reports, and in our reports to donors or to policymakers. That's.
Thank you. So moving on, we've seen a lot about how users can interact with the map and gain insights into what's going on in their regions of interest. And now I'd like to take you through the scenario planning element. So here, moving into another region where our stakeholders operate in Ghana. And coming down to the bottom, so we've got here the option to create a scenario. We can choose the basis for the scenario, and as you build up multiple scenarios, you'll be able to start from those instead of the baseline here. So moving on, I'm going to give the scenario a name and create it. And so within Ghana, one of their LDN targets is to restore and rehabilitate a forest land. And here we found a region where the tree cover has been lost. And so we can come into the scenario and edit this transition and say that, and for the purposes of this demonstration, I'm going to make it a bigger number, but we can change it here and save it. And this in turn updates our graphs. And so we can see now that we've increased the amount of tree cover in our scenario. You see the transition we made. And most importantly, although we haven't fully developed it here yet, you'll be able to see the effects on the summary table. So identify what are the effects on key metrics that are important to the end users. And I'd also like to draw attention that you'd be able to see the effects that you're making with these scenarios on moving towards the or lowering the SDG 15.3.1 value and moving towards LDN and neutrality. So moving on, I'd like to hand over to Luis, who's going to tell you a bit more about how we're planning to incorporate more complex scenarios into the tool.
Thank you, Simon. So in the future, additionally to the customized land conversion planning that Simon just explained, the user will be able to turn on and off the implementation of sustainable land management practices and then visualize in the map and in the table the associated gains in productivity. With this, we hope the user will be able to map anticipated future impacts of land use decisions for a given area. For example, the application of no-till practices has been reported in agriculture to widely improve soil organic carbon, which in turn then drives up agricultural production through yields. Leveraging on empirical case studies and peer-reviewed literature, we have already sourced the relative gains of soil organic carbon that usually come associated with implementation of no-till practices. We have the relative gains on yields for major crops due to the increase of soil carbon in the soil. And also we source it from the WOCAT database and some other sources, the per area investments, per hectare investments that are necessary to implement these practices of no-till. It's only now a small step to make this information dynamic in the tool as the user activates or deactivates the intervention. And this will be a big component of us moving forward. That said, the user can already assess the current state of agricultural production and yields in the table for its area from major crops, and also have an idea of the monetized carbon losses that have been associated with the land degradation in the past. And I hand over to Simon.
Thank you. So moving on to the work plan and the rollout. So regarding the work plan, I'd like to say, first of all, thank you for organizing the sessions with more land use planners. We've had a lot of great feedback and a lot of great ideas for items and further functionality that can be incorporated into the tool. And I think I'd like to start with one of the key questions that's coming up with the development of this tool as to whether or not we remain within the Google Earth Engine's apps functionality, which we're displaying here today, or move into a custom front end. And each of those has their pros and cons and will determine the steps required for users to incorporate private data sets and import and export the data they're seeing here now. Then on top of that, we've had feedback, and you heard from Ronel earlier, around being able to change the analysis level that the tool is operating at. So that's something we'd like to build in the near future. Another point is around the advanced settings, allowing users to determine which transitions are positive and negative, potentially remapping some of the land cover classifications, and other further advanced settings there. Moving on to the rollout plan. So we will first of all work closely with our core stakeholders and get the tool in the hands of as many end users with them, and then move on and make use of some of the connections that the competition organizers are able to provide to reach a wider range of users in the near future. We'll say that all of the layers and everything you've seen here today is working off global data sets, and so is already ready to be deployed globally there as well. Finally, this is an open source tool, and so for it to really succeed, we'll be looking to build a community around the tool, a place to share ideas, vote for enhancements, and really gain traction and interactions with the tool. So now I'd like to hand over to another one of our stakeholders, Steve Brescia, Executive Director of Groundswell International, who we have on video here as well.
My name is Steve Brescia. I'm the Executive Director of Groundswell International, and we are a network of NGOs working in 10 countries in West Africa, South Asia, and Latin America, and the Caribbean, promoting farmer-led agroecology and regeneration of communities and landscapes. So for us, I think this tool can be extremely important and valuable. We work with local NGO partners in each country, and then they work with farmers, community organizations, farmer organizations, and farmers themselves on their farms. And we think, like any tool, it's a question of what is the purpose of the tool and who has the power to use the tool. And in our work, we're really trying to shift power into the hands of farmers who we really believe are the key agents of change for regenerating landscapes, improving agricultural production, improving their lives and communities. And we call that agroecology, farmers working with nature to innovate and scale solutions and try to prevent negative trends. Farmers do that based on their own logic of what is cost beneficial to them. They of course have a deep understanding of that and what is improving their lives, and a deep understanding of the context they live in terms of the economic and political context, the security, the climate context, cultural context, et cetera. So farmers have to be the key agents of change at scaling out these solutions. And a tool like this, I think, can be really helpful at multiple levels for farmers to better understand how, in comparison to other communities that are perhaps using other practices, which practices are most effective. For our local NGO partners, so that's at the farm level and the between communities, and then for our local NGO partners to see again what is most effective and how they can bring these lessons on what is working to decision makers and policymakers to create the right kind of enabling and policy support environment. And then for Groundswell as a global network working across 10 countries, similarly, how we can demonstrate the trends and the power of agroecology to help to regenerate landscapes and improve lives and improve farming production. And so these are all extremely valuable information that if we can put in the hands of farmers and farmers organizations and local NGO partners, this can really help to improve our programs and demonstrate to others the value of this work and how it can best be scaled. So I think one element that will remain important is the human side of having people like those from Altus Impact to continue to work with our local NGO partners and farmers groups to best understand how this tool can be used, how they can most benefit from it, and how they can adapt it to their needs. So there's always a part of training and dialogue and adaptation at that level that remains important. Thank you.
Thank you very much, Steve, and thank you also to the other members of Team L for your presentation. We are going to return back to the presentation and to go to the question and answer session, which is again, like last time, a 10-minute exactly question and answer session. I've the pleasure this time to introduce Sarah Minnelly, who's going to be facilitating this segment.
Thank you very much, Michael, and thank you to Team L for the great presentation. I'd like to invite now our panelists to raise their hands if they want to ask a question to the team, and the attendees to type their question in the Q&A. I see we have the first hand up from Alex. Alex Volev, you have the floor.
Thank you, Sarah. If I can find the unmute button. Thank you very much for the presentation. I had one question on the, it was interesting to see, I think you mentioned that you sourced some of the information in terms of the impacts of different types of interventions on, for example, soil carbon from databases like WOCAT and other sources, which was interesting to see. Can you talk about how you might represent uncertainty in terms of either spatially, in terms of the impacts of different types of interventions on those outcomes, or just within the entire map as a number? Can you talk about how you might visualize that information?
Yeah, so currently, I think we saw from the presentation, we're not displaying the uncertainties, and it's a very valid point in terms of how do we do that, and we need to work with stakeholders and users and be very interested to work with yourself as well. In terms of how we can best display that. I see a number of options. One is adding that to the table. So we can add a plus or minus kind of level of uncertainty there, or how we can incorporate that into the map view as well. Yeah.
Thank you, Alex, and to the team for the response. Next in line is Neil. Neil, you have the floor.
G'day, thanks. That was a great presentation. I like that tool. Tell me a little bit more about what you talked about, getting lots of great ideas for additional implementation, but I think really the sort of the trade-off part of this is still to be implemented in any case. Tell me a little bit more about how much you've got to do on just getting that that trade-off part implemented.
So we'd be looking to build upon what we have, and so it's fleshing out and building out around the edit scenario screen, as Luis mentioned, in terms of enabling users to choose between different sustainable land management practices, and really this is work in progress, and we can really look at what's the best touch points to allow users to interact with the data. And I don't want to say it's fixed in any way. We can really work to see what works best with the end users. And then from the trade-offs table point of view, so we have a mechanism. Every time a scenario is created, it's going to generate the data there. It's just closing that circle with the respect to the calculation. So taking the SDG indicator, for example, when the land cover transitions are adjusted, which will in turn update the soil organic carbon changes, and any changes to productivity, how we then, well, what's the equation then to update that indicator? And we've got a clear idea of how we'll do that, but it's just building that out. So I don't foresee any major challenges in closing that loop there.
Yeah, and we also think that the fact that we're mapping different, for example, drought risks, fire risk, etc., you can build further layers that can allow you to increase your understanding of trade-offs. For example, by bringing in also understanding of high biodiversity, key biodiversity areas. So we believe that with time, land users will be able to appreciate more and more what's going on within the given landscape, and also, as mentioned, we want to build in, and we've already developed the first equations to get to basically illustrate the benefits of implementing no-till, which would then also allow to be displayed on a map areas where you have higher gains in productivity, thanks to the implementation of no-till relative to other areas because of the differences in soil organic carbon. And of course, that then translating those into actual monetary terms in terms of improvements in crop yields and the revenues earned from that, and bring in, using WOCAD and other peer-reviewed literature, economics of land degradation data, to actually have economic estimates on the costs of implementing these practices. But we do think that already now, thanks to the fact that we have this, the map view, users can appreciate some of the trade-offs involved in their land use decisions.
Thank you, Vanya. I'll now give the floor to Doug. Doug, do you still have a question? Because you had your hands up, but.
Well, I think my question was aligned with Neil's. I mean, I was the way I was approaching it is this looks to me right now like very much a diagnostic tool, and it looks very, very good. But I was just wondering, you know, how is the forecasting aspect going to be implemented, and especially in terms of understanding trade-offs? I think that was just answered. So you know, if there's maybe, you know, maybe I'll ask then my question that I asked previously, and that is, you know, in terms of trade-off scenarios and so forth, how do you go about validating, you know, future forecasts?
So I think I'll start by answering the forecast question. So currently we haven't got the forecast layers in, but we'd be very interested in working with Claudio's team as well, who it sounds like they've developed a computational neural network, which is going to be validated around ground source truths, to look at whether we can use that to make predictions on the land cover and the net primary product and the soil organic carbon data that we're using. And then the calculations that we had and demo today will run based upon those future years there. So by starting with data that's been validated ground source truths, we should help to answer that question, be confident in the predictions made.
Okay.
If I may add just quickly to Douglas, I think we also need to disentangle a bit the word forecast, because one thing is the forecast related to the land use, and it was shown on the previous presentation. The other thing is what we propose to do, to say, if you adopt this practice in the land, then you expect these benefits. And this is less of a forecast as it is being talked right now. So on that aspect, we can only say, well, we've searched the literature in other regions, people seem to have this benefit if they implement these practices. So your potential is this. Now, this is not a forecast, this is just kind of a potential measure. So just to make clear that there is the forecast aspect of the degradation, but also the kind of potential that we want to give the users from the implementation of measures. And this is not at the same level, just to underline that.
Thank you for clarifying that. That was exactly what I was trying to get at. Thank you.
Okay.
So I think we have 2 more minutes left. There is also a question from an attendee in our Q&A, which has to do again with the spatial resolution, basically, of the data sets you're using.
Yeah, so our primary driver has been to select data sets that are globally available, so that this tool can be used in any of the countries that have signed up to the LDN neutrality targets. And with that comes some limitations. Generally, the global data sets are at around 500 meters resolution, or some cases down to 250. So we've used the lowest resolution where possible, but the constraint of having global data sets does mean that the majority of our data is at 500 meters.
But with time, we would also like to be able to help users feed in their own data. And I think Peter Goebbels, who's also with us on the call, Director for Action and Learning for West Africa for Groundswell International, has mentioned notably the importance of being able to work at smaller scales so as to really understand what is the impact of their interventions in this one given community. Yeah, and Peter as well, don't hesitate to jump in if you have any comments as well as a future and present user of the tool at any stage.
So we have only 1 minute left. I think there was a question from Baron via the chat. I'm struggling to read now on the screen. Baron, do you quickly want to ask your question? I think you can just take the floor as a panelist.
Sure. So I just wanted to know, when Luis mentioned the WCAT best practices, if there's a spatial explicit element to that, right? The database is very rich, but the location of where those practices are appropriate is not as easy as it might be. Are you automating that process to make that element function?
The best that we can do in that respect is to go to the WCAT database and at least filter by some biophysical parameters where the approach has been implemented, has been documented to be implemented. So they don't pinpoint latitude, longitude, here it has been, but it's say with slopes between 10% and 50%, yes, and with rainfall between this and these ranges. And it will be, I mean, we will have probably 2-3 criteria around that. And then, of course, sourcing from Google Earth, where is the precipitation, where is the slopes, and so on. Try to then kind of find the analog region where this would be better suited. But beyond that, at the moment, I don't see we moving much beyond that. So, to be honest.
And I think we will use WCAT also mostly for actual cost estimates of implementing sustainable land management practices. Work can be done in terms of improving or standardizing their measures of yields and productivity improvements so that it can feed into tools like ours.
Yeah, so I think just to add to all of that, will allow users to edit those pieces of data within the advanced settings, but until a point of time that we can either access through an API or we can extract the data from the WCAT database more automatically, we'll set the defaults and then users will update those values.
Thank you, Simon. Forgive me for cutting you short here, but we really have to run a very, very tight ship. Thank you, Sarah, as well, for the excellent moderation there. We're going to move on to our final contestant now. Team N and Pythagoras are going to put you in charge here, or hand over the microphone to you, and I will stop sharing and you can share as you see fit.
Okay. Can you see my screen?
Yes, we can see it, or at least okay. I can see it, yes.
Okay, so my name is Pythagoras Krambi-Peris. I'm a leader of Team N. And I will give you a live demo of our tool entitled Loop for LDN. Loop for LDN integrates a land degradation neutrality into participatory land use planning via an interface that allows users to evaluate land use management transition scenarios, providing visual and quantitative representations of land degradation gains and losses. It highlights the 3 LDN sub-indicators used to anticipate future land degradation, helps users to identify best suited sustainable land management practices, and to formulate land use transition scenarios and support them in evaluating and comparing impacts of scenarios on ecosystem services with links to GOC, VOCAT, TrendJERT, and TLD. In Loop for LDN, land use plans are organized under projects, under which users can collaborate on defining their plans and observing the results on land degradation. Via the authentication and authorization mechanisms of the tool, each user has access only to the data and information of the projects they own or participate, thus ensuring that they have a complete control of who can view and modify their content. This ensures optimal security for the data stored in the system. To create a new project, the user clicks on the relevant options from the left menu, which leads to the project definition panel. Here, they are called to submit a name, an acronym, and optionally a short description of the project. And define the area they will use for land use planning, starting at the country level and potentially going deeper into the first and second administrative areas. Let's select an area here. As soon as the basic information for the project is defined, the user is led to invite other members in the project, and so as to form a team for collaboration. In the background, country-level information is populated, referring to the specific country's LDN targets as defined in UNCCD. Its risk profiles in terms of climate change impact, natural disasters, and so on. And finally, its prospects on factors related to climate change, namely population, temperature, and rainfall, and NDVI indices. All these variables use open data from trusted sources. You can find links in all the default for all the data sets used. But in any case, the full-fledged tool will allow users also to upload and visualize their own relevant data sets. Moving to the region of interest, the history menu provides access to historical data on the region's land cover distribution, both on a map level, presenting the different classes for the different land cover types, and also diagrammatically to have a better understanding of the distribution of the different land use types for the selected region. The same approach is adopted for the region's organic carbon stocks. It takes some time because the tool is live, where you can also compare some baseline statistics between the country, the soil organic carbon stocks at the country level and also at the level of the region of interest. And also, you can see also the vegetation productivity index for the different years and the corresponding land degradation observed in the last two decades as retrieved from data coming from TransEarth. Again, in the finalist tool, the user will have always the option to use their own data if available for its land degradation sub-indicator, or to upload custom land degradation maps. An important step before planning for LDN is to understand where is most critical to focus land restoration efforts. To do so, we need to assess either the suitability of the adopted land use types of the region of interest or the sustainability of the adopted land management approaches. In the first method, which works better at the regional level, we overlay the existing land use type of an area with a land use type which fits best for this area. Having a non-suitable land use type indicates a high risk of introducing land degradation in the future. This process generates a map depicting already degraded areas with high risk for future land degradation, where we should reverse and reduce land degradation, already degraded areas with low risk for future land degradation, where we should reverse land degradation, and currently stable areas with high risk for future land degradation, where we should put effort to avoid future land degradation. Going back to the second method, the second method is applicable in smaller focus areas with known details on their land management approaches, where local community stakeholders have the capacity to assess current land management approaches and take decisions towards more sustainable ones. At the first step of this method, the participants agree on the set of impact indicators that will be used for assessing the sustainability of the different land management approaches. These impact indicators are retrieved from WCAT and TLD and are organized in three different categories: ecological impacts, such as soil, water, biodiversity, and climate change resilience. Socioeconomic impacts, such as production and economic viability. And sociocultural impacts that have to do with indicators relevant to food security and equality of opportunity. Next, the user selects a focus area over a map, either by designing it over that map or by uploading a geopolygon defining the area. For each LU type found in the defined focus area, the group provides their evaluation for the SLM approach used in the land use type using the agreed impact indicators. And based on this evaluation, just a moment to put some values. And based on this evaluation, they decide on what is the anticipated land degradation impact for this land usage type in the focus area. As soon as the process is completed for all land use types found in the focus area, similarly to method 1, the user proceeds to the anticipated new land degradation map. So as to understand where is most critical to focus land restoration efforts, and then the user can start planning for LDN. The planning process relies on the creation of consecutive transition scenarios where the user defines the size of areas to be changed, let's create also another one and transform some grassland to cropland. And the users will be able to define the area of intervention either on a map or to upload geopolygons in the form of a GeoJSON or a shapefile. The transition impact is calculated based on the transition impact matrix for the area, following the approach adopted by TrendZERF. This matrix is fully customizable. So in the case that you would like to change something, this functionality has been already there. As the user defines the plan transition, the gauge meter, as I showed you before, in the LU planning page indicates the perceived impact of the interventions in the focus area. After the definition of the transition scenarios, the user is presented with SLM practices coming from VOCAT applicable to the scenarios defined. Following the relevant links, each user can visit the corresponding VOCAT page and go through the detailed information for each SLM and has the ability to assess. Let's select this one. And he has the ability to assess in his or her own opinion what the expected impact will be after the adoption of this specific SLM. The user is able always to compare between the current LU system as it has been discussed and agreed along the members of the team, and compare with his own assessment before proposing this SLM to the team on the anticipated impact of the LU system implementing the selected SLM. The list of SLMs presented here, we use the socioecological index from GEOC in order to derive SLMs applicable for the region that we have selected previously. So the hypothesis here is that areas that have the same socioecological index, most probably SLMs that have been used successfully in such areas are also applicable in the area of our interest. Then we can move to the next two sub-indicators, the soil organic carbon and the vegetation productivity. These two sub-indicators are variables determined after the natural response of the plant land use and land management. So the calculation of their projection can either be skipped, which is the default step, or in case that we have data or model that we can trust, then we can use also either our data or some type of modeling that we can rely safely for including also the impact for these two sub-indicators in our plan. So here in the soil organic carbon, we have the soil organic carbon coefficient matrix, which is the approach adopted by TrenchEarth, where we provide the default. The user can select which climatic type fits best for this case and load the default variables, or the user can change, can modify depending on a good knowledge of what is happening in his or her case, and also include this dimension in the estimation of the scenario. The same, similarly, the default option for the use of the vegetation productivity sub-indicator is to skip the indicator. However, in the full Loop for LDN version, we plan to provide also the alternatives of using either custom NDVI projection data or using gridded maps of NDVI projections. When the plan is complete, the user can view the corresponding neutrality matrix. Via the Land Degradation Neutrality Matrix interface, users can view details on the LDN impact of all scenarios developed in the project and view or export the relevant neutrality map if previously they have defined the geopolygons for the corresponding interventions. Furthermore, they will be able to export a report for this LDN impact analysis, encapsulating all data supporting the impact assessment. And additionally, the users will be able to produce a dashboard that uses data from all the projects referring to a given country that they own or participate, representing the contribution of the plans produced by this project towards achieving the country's LDN targets. These two functionalities are foreseen, among others, in the Loop for LDN 9-month implementation roadmap. The roadmap's main milestones refer to the completion of the tool's functionality by May 2021, the optimization of its infrastructure in August, its scaling up to global coverage in October, and the execution of Loop for LDN capacity building activities during November and December in order to ensure tool uptake, long-term stakeholder support, and long-term use. Throughout the process, throughout the development process, iterative piloting will take place with our stakeholder representatives from Tunisia and Burkina Faso to ensure the completeness and robustness of the tool. This concludes the presentation of our tool. In case you want further details on the data sources used in Loop for LDN, you can visit the relevant page and follow the provided links, while the complete source code is published in project GitHub repository and is also accessible via our tool. At this point, I would like to introduce our user representative, Mrs. Atia Rafla, from the Ministry of Agriculture in Tunisia, to provide her feedback.
Yes, I can speak.
Yes, please.
Could I speak?
Yes, please.
Yes. Thank you for organization. I'm so happy to assist with you and to transmit our needs and our interest for this aspect of LDN. So I'm Atia Rafla from Ministry of Agriculture of Tunisia. I'm soil director. So in Tunisia, activity related to LDN are coordinated by a National Desertification Council with the participation of several institutional and civil society actors and different levels, including the Directorate of Soil Resources. So as you know, to achieve land degradation neutrality, we need to develop, to assess, to monitor land degradation process and vulnerability of soils, to prioritize assessment criteria of different land management. We need also approach to support decision maker and all stakeholder to plan, to manage, to restore degraded soil. So I think that the look for LDN is a really opportunity to support our soil, our degraded land, and to how provide, and it provides also many useful tools to provide useful data. This is very important. We can make also information system about land degradation, extension of land degradation, spatial data. This is very important. Where is the land degradation? How to proceed? How to restore? To select area and SLM practices to help decision maker for territorial planning SLM, and also to implement and scaling out sustainable land management to achieve land degradation neutrality. So I appreciate so much the succession of steps, because there's meaning, this is meaningful succession of steps. We begin with the development of thematic maps to reach identification and setting up of indicators concerning ecological, socio-economic, and socio-cultural aspect. So I appreciate also the pentagon of the polygon of classification of set of indicators. This is also provide very interesting data about the extension, about the classification.
Thank you, Ms. Rafla. I'm
Just
sorry, I had to cut you off.
Yes,
Go ahead.
I appreciate
Very
also
quickly.
the matrix impact and that leads to land management and how to proceed. Thank you very much.
Thank you. My apologies for cutting you short, but you're not the only one that I have to cut short. So we appreciate your input here. We must move on to the question and answer segment. So that means, Pythagoras, I'm going to stop sharing your screen and start sharing my screen again. And I'm going to welcome Anna again to moderate the segment here, the question and answer for Pythagoras segment.
Thank you very much, Michael, and thank you again to Team N for their participation. Once again, an invitation to the panelists to raise their hands, to ask questions or make comments. And once again, to all the audience to use the Q&A panel to type their questions. Several teams have actually already addressed some of the questions that were typed in directly. Thank you very much for that. I see Neil has,
Neil has his hand.
his hand raised. Neil, the floor is yours. Thank you.
Thanks very much. Another fantastic tool. They're also different, these tools, but they're providing really fantastic opportunities in different ways. Well done. Thanks for a great presentation. Can you tell me a little more about the analytics behind the sort of those spider web charts or whatever, the actual trade-off analysis there? You mentioned something about using a JRC method or something. Can you tell me a little bit more about how those trade-offs are actually calculated, please?
Yeah, the trade-offs are not calculated. The assessment comes from the expert knowledge. This is the part of our tool where it implements a participatory approach among the different stakeholders participating in the team. The GOC, the socio-ecological index that comes from GOC, is used in order to filter sustainable land management approaches from VOCAT and to propose those ones to the experts. And then the comparison, the trade-off analysis is taking place between the analysis of the experts that have the real knowledge of the specific focus area and the details of what's happening at the real life in the area, with their proposition, their proposals for introducing, for adopting different SLM technologies coming from VOCAT. So it's this part is not automated because you cannot find any data that is more trusted than the real stakeholders and the real experts' opinion. So this is the part of our tool which is participatory, and this is why we moved beyond the idea of having a tool that provides data to have a tool that also can organize teams together and gives them some basic also collaboration facilities like chatting, exchanging ideas, exchanging files, data, the ability to work on their own data, and so on.
Right, thank you.
Thank you very much to Neil and Pythagoras. And next, I would hand over the floor to Peter Verberg. Peter,
thank you very much, and thank you for interesting demonstration. I have a question to you about the maps that are very central in your tool that indicate areas that are at higher risk, so you have to avoid degradation there, and areas that are at high potential for restoration. How do you determine the higher risk of those areas, and are there any ways for the user to find out what's the main factor determining that risk? Because if you have to avoid it, you have to know what is causing it. So is there any kind of causal tracing that the user can do in the tool?
Yeah, at this point, we compare in the current version of the tool, we compare two things. We compare the land degradation observed in an area in the last decade with a data set coming from GLS, which contains ideal classes for land use. Obviously, the same mechanism can work if you replace the GLS data with another data set that you have and you think that this is the definition or a blend of data that you consider as defining the risk. So if your risk comes from example, for a data set that deals with fire or with some other risk, you would be able always to replace that part, and the comparison will happen between the observed land degradation and your risk map. And the idea is that areas that are observed having already land degradation along with high risk are those ones that you need to reverse and reduce. Areas that have low risk but they have introduced land degradation in the past are considered as areas where you need to most probably only reverse. Whereas other areas are areas that are stable in the last decade, but based on the map that we introduced there, they have a high risk. So you need attention in order to avoid having the new land degradation. And after that part, all the comparisons and the neutrality matrices are generated based on the measured areas over those maps and the measured areas over the anticipated new land degradation. So this is a part that we will work on in our full version of the tool, if we are selected, to support the ability to modify the default GLS content with the ones coming from the user. And this stands for all the parts of the tool. We have developed the backend so as to be ready to be adopted depending on user specified data. So if the users upload data of high resolution, for example, then we have a mechanism at the backend either to downscale or to upscale data so as to unify, to uniform the resolution of all the data sets that are acting take part in calculations. And also if a user perhaps uploads land cover maps with more details in their classes, then again the tool has the ability to modify itself and to support the user-defined classes and not only the ones, the 7 ones that we are familiar with via the Trench-Earth. So these are the parts that the tool will actually transform itself to cover data that come from different ministries, different user-defined sources.
Thank you, Pythagoras. Thank you, Peter. We have the raised hands from Alex and from Douglas. I would hand over to Alex first, and let's see if we have time. Please go ahead, Alex.
Definitely, thank you, Anna. And again, as others have said, exciting to see 3 very interesting but different tools. I have a similar question for this team as I did earlier. Can you talk a bit about what it would take to globalize this tool? I know that right now the focus is on Burkina Faso and Tunisia. And then also a related question, the trade-offs analysis in the spider diagrams that Neil asked about, given that that's based on expert analysis, is that information that could be transferable to other places, or is that site specific?
I will start with the latter one. I don't know to which extent the information for an area that is an expert assessment is transferable or not. I assume that this depends on similarities of the landscape in different areas. But coming to your initial question, which is more in our area in the data in the data side. Sorry, I forgot the question. Can you repeat that?
No problem. It was about globalizing the tool.
Okay, sorry. Yeah, all the datasets that we have behind the scenes are global datasets, as you can observe. The technique that we use in order to decrease the computational need that happens behind the scenes is that we clip and we work only on the data coming from one country. So this is why at this stage the tool seems to work only for Burkina Faso and Tunisia. In practice, the tool can work similarly for all the countries. But we don't. We have not enabled in the interface the ability to select other countries, just to be sure that we haven't checked everything for different countries. But the idea is that it's not a tool that works for at this stage for data coming for Tunisia. It works for with global data, but we clip in order to keep all the computations as low as they can be, because this is very computing demanding thing, and all the techniques that can lower this, I think are worthy to examine.
Thank you very much, Pythagoras. Thank you to all participants. Over to you,
Thanks.
Michael.
Thanks very much. I'm so sorry again to have to cut you off. We have just a couple of minutes for questions, general questions now, and I'm going to hand over the microphone to Sarah. But please keep your questions very brief. We don't want to run out of time before we have a conclusion here today. Go ahead, Sarah.
Thank you very much, Michael. We wanted to have a little space here in case you have any question on next steps. We have the evaluation, of course, coming after this demo session. We are preparing for the award ceremony and then for the future work ahead with the winning team. So if there is any specific question at this stage, I would be happy to take it, or obviously you can also contact us anytime via email following this session, and we will be happy to respond.
Yes, feel free to answer, enter any question you might have, a general question into the text chat. And please do understand that we do want to give you a proper conclusion, and I interpret the lack of input in the text chat as meaning no questions. So I'm going to rush over to Doug. Doug.
Let me just say one thing, Michael.
Yes, Sarah, go. I'm sorry. Yeah, go ahead.
I just wanted to say that I think we're very happy with the level of participation in all of these events. And we would like to invite you all to attend the award ceremony on the 19th of March. Unfortunately, due to some technical limitation of the platform we will be using, only selected invited speaker will be able to physical or virtually attend the event itself, but everyone else can follow the live streaming on the UN web TV channel. So we will publicize this through our social media channel, and we are all invited to attend.
Yes, and it's also on the last slide of the presentation today, so you'll be able to see that. Right, I'm going to hand over now to Doug for a wrap up. Doug.
Okay, thanks a lot, Michael, and thanks a lot to everyone for the really interesting presentations. A lot of effort has gone into this. I'm just going to, in closing, say a few words about GEO. Again, why is this the GEO LDN initiative, and why is this competition happening in the context of this initiative? As I'll just recall quickly that GEO is an intergovernmental partnership with over 120 different governments that participate in a best efforts endeavor to open up access to Earth observations and coordinate those. And in particular, the GEO Land Degradation Neutrality Initiative is helping national and local actors in all countries use Earth observations to achieve LDN, as is set out in the Sustainable Development Goals, and in particular, of course, 15.3.1. And this is a unique stakeholder-driven initiative with a clear policy mandate from the UNCCD. The GEO community has a lot to offer in ensuring healthy and productive land resources for future generations. We need more rational land management and planning in order to provide the food, water, fiber, fuel, homes, and livelihoods for an expanding global population. So Earth observation applications are at the cutting edge of land degradation neutrality assessment, planning, implementation, monitoring, and reporting. So on behalf of the UNCCD, GEO, GIZ, CSIRO, Conservation International, and all of the organizers, I'd like to thank each of the teams for their hard work. And I congratulate you for reaching this final stage of the competition. The task of choosing the winning project will not be an easy one, but each of the teams can be proud of the contribution that they are making in support of more transparent and well-informed land use decisions at the local to national levels across the globe to achieve land degradation neutrality. Just a quick reminder on the next slide of where we're going to go. So as Neil mentioned at the outset, the committee for the review of the implementation of the convention is going to wind up its discussion on the 19th of March, and that's the day on which the final winner of this process will be announced. And my last thought to leave with you is something that our director, Gilberto Camara, said a couple of years ago, that the group on Earth observations is working to create a broad global network of Earth observation practitioners who are in control of the tools they use, not just consumers of information. In other words, bringing into the equation the co-design aspect, as we have seen here, land use planners being involved. This is something that is critical if these applications are going to be relevant to the end user. So that's it from my side. Thank you very much. Back to you, Michael.
Thank you, Doug. Yes, we're looking forward to seeing you on the 19th. Again, the link I'll show you in the following slide. So looking forward to seeing you at the very exciting awards ceremony. I hope we can get some sleep until then. And yeah, it's coming up very quick. So looking forward to seeing it there. You can watch the orb ceremony by following the link here, and get in touch with us. Give us some feedback today. We normally have a feedback slide, but we, due to time, didn't have time to do that today. But please send us your feedback, maybe a quick email or something at the address you see down here, or you can informally leave it in the text chat now. What did you like? What can we improve? And yeah, looking forward to see you at the award ceremony. And thank you again to all of our speakers today, and to the entire team, and to the proposal presenters. And yeah, good luck. Bye-bye, everybody.